This is my Linux testing machine in the Fractal Terra with a 7900 GRE that has ample room for clearance. There's not -1 millimeters, there's all kinds of millimeters of clearance. Yes, the Steel Legend 7900 GRE, 16 gigs of VRAM, ASRock special AI utilities, AI quickset for Linux and Windows, ASRock doing special stuff for Linux. We're also going to do ultra-wide testing, 3840 by 1600 and 3440 by 1440 on our GRE graphics card, 16 gigs. Is it going to be good enough? Yes, it's going to be good enough because it can do 4K, but that goes without saying. Let's dive in. Steel Legend. Alright, let's talk. 7900 GRE. The Steel Legend. This is the smallest 7900 Steel Legend that I've tested. I don't have the reference version of the 7900 GRE. It's maybe a little smaller, but it has a weird VBIOS overclock lock, which is strange. ASRock is sort of positioning the Steel Legend series, whether it's motherboards, GPUs, whatever, as kind of like, this is the value bang for the buck. Like, give us your money, and we will make sure you get the most value possible for your money, but you're still kind of an enthusiast. So you want overclocking and you want everything else. Maximum boost clock on this with my overclock, 2425, and it would basically stay at that boost clock in most games pretty much continuously. I did have to tweak the power target and I did have to ramp the fans, and these 3 fans can get quite loud at their maximum setting. You don't really need to do that though. Between HyperRX and other features in AMD's Adrenalin software, you mostly don't have to do that. If you missed our GRE launch day coverage, you should really check out our GRE launch day coverage, because we have the full benchmark breakdown using this GPU as it was at launch for 4K, 1440p, and 1080p. Spoiler alert, the GRE is basically good enough for 4K gaming, maybe not with the absolute highest texture pack, but pretty darn close. But these monitors behind me, they can do 100 Hertz and beyond. And maybe that's what you want. Maybe you want to run at 3840 by 1600 ultra wide, but 144 FPS, and you're going to have to use FSR, and you're going to have to use some upscaling technologies, and you're not going to get that with ray tracing. No matter which team you want to buy a graphics card from, you're going to need upscaling technology for really high resolution, because the monitors do look really good when you run at a native resolution. So okay, fine. Outputs on this card: 1 HDMI and 3 DisplayPort. The HDMI is not fully functional under Linux because of the HDMI consortium. The HDMI consortium needs to get with the program, the open source. This is a pretty standard rant that's going to appear in most of my videos. Basically, AMD did all of the work, bent over absolutely backwards, to support HDMI 2.1 with Linux and open source drivers. And the HDMI consortium will not get with the program because it's 2024. The entire planet runs on Linux except for desktop computers, basically. Phones, routers, servers, basically everything except desktop computers. And the HDMI consortium's like, we don't know, people might steal our content. Again, they're living in the 1960s, and or it's the worst version of capitalism as explained by Cory Doctorow. Like, they want moats, and it's not really about intellectual property controls or protecting things. It's really just being able to charge you money to have the little HDMI sticker. I really like the way that Intel dealt with this situation, which is all of the outputs on their GPU are DisplayPort in hardware, and then they add a built-in HDMI adapter. So there's a DisplayPort to HDMI adapter chip on the PCB that does DisplayPort to HDMI conversion to avoid the HDMI consortium's shenanigans, because Intel knows that a lot of people using open source are going to be really interested in their GPUs. There is no solution like that I know of from any board partner from AMD, because, like, as an electrical engineer, like, thinking about it from their perspective, that's literally the dumbest thing on earth. Like, the physical silicon in the GPU is capable of speaking HDMI signals. Why would we do that? And idiot, greedy people inside of the consortium who are decidedly non-technical have decided that, oh, we can't release the drivers to use the hardware that we already have, so HDMI should go away. DisplayPort is the superior technology. Anyway. Okay, widescreen gaming, I was a little skeptical. I mean, okay, about 1 million of you have written in to ask, hey, what about benchmarks for widescreen gaming? And I kind of get it now. In the beginning, I was a little skeptical. After having gamed for a while for this video, to played some games for a little while in a widescreen mode, I kind of like that the non 16:9 aspect ratios line up a little bit better with your peripheral vision, but I still like 4:3 aspect ratios or even portrait aspect ratios for programming and everything else. I have a really hard time getting behind 21:9 or even 32:9. We didn't get into 32:9 for this video, but I have a really hard time getting behind it in general. But I get it. But that's just me, so that you know where I'm coming from as I give you these numbers, because this was more interesting than I thought. Assassin's Creed Mirage, okay, 1080p, you can expect 161 FPS average. In the same configuration, you're going to drop off to 136 FPS when you take it up to 1440p, and from 136 to 110 FPS to go to 1440, 3440 by 1440. That is more of a drop off than I expected. It's a very similar performance to 3840 by 1600. 101 to 110 FPS, and 3840 by 2160, that is 92 FPS. So basically, if you're doing 3440 by 1440, it's really not a lot different than 3840 by 2160, which is surprising. Cyberpunk, okay, this is exactly the opposite result. It makes no sense. 159 FPS at 1080p, 104 FPS at 1440p, 3440 by 1440, ultra-wide, 76. 3840 by 1600, 61. 43 FPS at 3840 by 2160. This kind of doesn't make sense. To drop from 61 to 43 FPS? Why? What's going on here? And 3440 by 1440, subjectively, buttery smooth on this configuration. Cyberpunk's just a weird game in general, but this performance fall off is what I would expect, basically, just based on the number of pixels, except for 3840 by 1600 versus 3840 by 2160. Like, we didn't give up that many pixels. Why does the performance fall off that dramatically? Shadow of the Tomb Raider is kind of similar, 118 FPS at our 3840 by 1600 versus 88 FPS at 3840 by 2160, just standard 4K. You get a pretty significant performance bump if you're gaming at 3840 by 1600. Can we configure a 3840 by 2160 monitor to actually run at 3840 by 1600 with black bars on the top and bottom? That might be the secret to high performance gaming when we're talking about 21:9 aspect ratios. Baldur's Gate 3, not really a lot of difference. 3840 by 1600 and 3840 by 2160, basically the same performance. While 3440 by 1440 is quite a significant performance fall off from 2560 by 1440. In fact, 3440 by 1440 really not a lot different in terms of gameplay experience than 4K. That is a little bit of an unexpected result for Baldur's Gate 3. Borderlands 3, an ancient title. This is just a game to get our bearings. And yeah, this breakdown is kinda sorta what I would expect. 144, 108, 91, 84. So really not a lot of performance difference between ultra-wide 21:9 3840 and 3840 by 2160 4K. I'm surprised that the performance fall off is as much as it is between 2560 by 1440 and 3440 by 1440 ultra-wide. I wouldn't expect that much. And these are the specific games that I picked out of a huge, probably about 30 games. These are the ones that I played the most in order to try to see what it felt like. These are the ones that behave the most differently. And so, you can't just look at a particular game and say, this game is going to behave this way, or this game is going to behave that way. I think Assassin's Creed Mirage is one of the worst case scenarios that you can expect. Basically, when you move up to 21:9, it's going to perform terribly. Borderlands 3 is a pretty good example of your worst case scenario, which is when you move beyond 2560 by 1440, the performance fall off is really sharp, and it doesn't really matter what resolution you're running beyond that. The performance is roughly equivalent to 4K, or within spitting distance of 4K. I mean, okay, 3440 by 1440, 108 is way better than 84, but I would have expected it to be a little better. So there you have it, ultra-wide gaming. I think there probably should be a lot more content on ultra-wide gaming based on this, a larger database, just running at ultra-wide resolutions. You could also use technologies like XESS and FSR3. They behave a little differently when you're talking about ultra-wide resolutions. You don't always get a really amazing result the same that you would on a 16:9 aspect ratio display. It matters more than I thought it would, and it matters more than it did historically. I find that very interesting. I have more work to do, I think. Now, in terms of off-label uses, ASRock is leaning hard into the AI thing. They've created 2 pieces of software, one for Linux and one for Windows, to help you lean into AI as well, that will work on their GPUs. And that is AI Quickset. This gives you stable diffusion and a large language model and a comic book / manga translator, which uses AI. So if you download the original PDFs, you can translate it to English because, again, intellectual property controls, it's like, okay, here's the translated thing. How do we upload that so somebody can enjoy it that can't read the native language? Well, now we can just solve those problems with AI. So this is a download, and it's pretty easy to run. I've actually got AI Quickset running over here on my Linux machine, generating lots and lots and lots of serial. I don't know. If you're watching this and you don't have an ASRock GPU, but you still want to play with AI on an AMD GPU, because you do have an AMD GPU, because AI is the new hotness, check out AMD's Rock'em blog, because they just changed the blog for how they do AI. And this is the place to go to keep an eye on AI happenings on AMD RDNA hardware. CDNA is the commercial enterprise workstation class stuff. RDNA, well, there does exist RDNA for workstation as well, but RDNA for gamers, yes, you can finally leverage AMD GPUs for AI. AMD is catching up fast, so you can run Stable Diffusion. If that was your reason for, buying a GPU, you can now do that on AMD as well, and get more VRAM. 16 gigs of VRAM, 20 gigs of VRAM. Pricing for this at the time I'm doing the video is around $600 US. This seems to be sort of the new upper high end echelon. If you want to play games natively at 3440 by 1440 at a really high frame rate, 7900 GRE is probably your best bang for the buck. NVIDIA doesn't really have anything in the same price class, although NVIDIA has been adjusting their pricing the last couple of months. I guess AMD finally has their attention. And AMD's also facing a lot of pressure at the low end from Intel with their GPUs, because Intel is very, very hungry for this GPU market, and Intel's driver team is really catching up fast to AMD. AMD's drivers historically, everybody would sort of rag on them, but AMD's drivers have actually been really good for a couple of years now, and GPU Open and other stuff that AMD is working on for game developers and that gamers will indirectly enjoy has benefited the industry tremendously, and it really underscores how far AMD has come and how close AMD is to parity with NVIDIA when we're talking about drivers, when you look at where Intel's drivers are and how far Intel's drivers have come since the A770 launch. I mean, Intel's performance is like plus over 100% in some games since launch. AMD's driver team has gone through some growing pains in the past, let's say, but they've come a long way, and AMD has really got a lot of polish in their driver these days, Adrenalin and HyperRX, and it's so good that NVIDIA recently changed it so that to get all of the same kind of like game enhancement, let me help you configure your games and save time features, NVIDIA used to force you to sign in to get those features. NVIDIA has taken that out because people are tired of signing in and getting spammed, and it's a story for another day. Anyway, that's been a quick look at the Steel Legend 7900 GRE from ASRock. I'm Wondalist Level 1. If I missed anything, or you have any questions, or you want to see anything Linux specific, let me know, and we'll take a look. Alright, I'm signing out. I'll see you later.